In this chapter, we want to talk about technology, production, and cost. Uh, Actually, production and cost, because any production process has to be accompanied with some sort of technology. So the chapter is focusing mainly on these two sides of a production process, which is production and cost. And the notion of production is related to the use of resources and how to turn these resources into output. And this should go into some sort of production process. And resources, you can call them inputs. And usually, firms and industries use many inputs, and we covered them that there are main four inputs: labor, capital, nature, which is land, materials, nature, and the organizer or the owner who looks for profit. So it's organizer. Because the organizer collects all these resources into a mix and then sells the mix in the market to make a profit. So anyway, any production process consists of one input or two inputs or more. Some of these inputs are variable and others are fixed. Fixed means like land, building, variable input that changes with level of production. So if you want to produce more, you need to hire more labor and get more materials and more time. So all these inputs are variables. But fixed inputs like building, land, they are fixed and it may not change with the level of production in the short run, but maybe in long run, if the company wants to expand its operations, it could hire or get more land or get more buildings. And bear in mind that we will focus on these two elements on the production side of the market, which any firm or industry cannot do their business without them. The fact of industry or firms want to produce and they incur costs. So we will divide this lecture into two parts. One main part is production, and the other part is cost. So production is related to output and how much input you will use to produce any output or output level. But for the cost side, we will use value, which is the price of the input multiplied by input, and this gives you the amount of cost. So if output is X, so if you multiply P, which is the price, by input, this gives you the cost of X. But before we uh, talk about production side and the cost side, we will go through some elementary notions or concepts which will come in the coming slides. So technology or production. is a process of turning inputs into outputs using certain level of technology. Technological change when there is some advancement in technology which enable a firm to produce level of output using some level of input. So you could use some technology which will rely on level of input, but it gives you a certain level of output, or you could use the same level of input, but gives you greater level of output. Or for a given level of output, you will be using smaller level of input, which makes some savings. So this is called technological change. This is an example about Walmart, I think, and Carrefour. And these two companies, I think they use some level of technological change to give that relationship between level of input and level of output. Next slide. This slide also talks about the fact of when inputs can change, because in the short run some of inputs you cannot change, but in long run all inputs could be changed. So we call short run if at least one of the inputs is fixed, but others you can change. But at least one of the inputs you cannot change. It remains fixed. So this is called short run. But in long run, all inputs can be variable and can change over time. So there is no mention of how many years or how many period. It is just related with the fact that in the short run, some of variables remain fixed and you cannot change. But in the long run, all inputs can be changed. Okay, in this slide, more focus on the cost side. So we as economists, we look at costs consisting of variable costs and fixed costs. These costs that cannot change in the short term. For example, rent of land or rent of building. Usually these are related to a contract that cannot be changed in the short term, in the short run. And whatever production level is, whether the firm produces or doesn't produce, the firm still has to pay this fixed costs, fixed cost, or so like rent and other things that are constant. So if production level is 0, or if it is 100, or if it is 1,000, this fixed cost has to be paid and cannot be changed in the short term or short run. Variable cost is tied with the level of production. So if the firm produces nothing, so no variable cost will be paid. And whenever production level is positive, then variable cost will appear. And if we add variable cost plus fixed cost, this will give us total cost, which can be expressed in this formula. Total cost equals fixed cost plus variable costs. So this is variable cost and this is fixed cost. This is an example of fixed and variable cost. I want to remove this one because it confuses you if you look at it. But anyway, as we said, this is fixed cost, rent. Salaries are variable cost because the more you produce, the more you hire labor. And rent, you have to pay the rent whether you produce or you don't produce. And these types of cost also could be considered as variable cost because it is related with the activities. The more activities you have, the more you will pay this. There are also other types of costs, opportunity cost, and this is related to any cost because of making choices. So the amount of return that is lost from second choice. So this loss is considered cost because you will choose choice one. Explicit cost, a cost that involves spending money, so you know the exact value of this cost. So you know the value of rent, you know the value of salary, you know the amount of utilities you will pay. You know them all, or the firm knows them all. Implicit costs, you don't know the exact money or the amount of this cost, so you have to pretend it or assume it, and then you consider it later after you determine how much that cost could be. For example, opportunity cost. You don't have any exact information about this type of cost, but you might consider it in a specific number. But you don't have any bill or voucher or invoice. So some examples of implicit cost: foregone salary. This is because you chose not to work in a job that might give you higher salary. Foregone interest, when you use your money to engage in a business. Meanwhile, that money, if you put it in bank, it could give you some return like interest. So this is foregone interest. Depreciation is also a value that you determine. So all these values or amounts are implicit, and then all of them get considered in the total cost. In the coming analysis, we are not going to talk about these. We will just focus on the variable cost and fixed cost and total cost, and some additional analysis related to them. Okay, now we will go to this numeric example that shows production and cost. And these numbers and columns will show you the relationship between cost and production in the short run. So if I divide this table into two portions, so this portion talks about production, and this portion illustrates cost side of this firm. This firm produces pizza, and to produce pizza, this firm hires or utilizes two resources or two inputs: workers and oven or ovens. So if I'm going to write production function of this activity, so amount of pizza or quantity of pizza is function in labor and ovens, which is capital. So L is workers and K is capital because this oven, they purchased it to produce pizza, and they have two ovens, and as you see that this oven is fixed input. So if they produce nothing or if they produce more positive, they still have the oven. And because at level zero, because they don't produce, so they don't have any workers to hire. So workers or labor is a variable input. And this input, which is labor, is increasing because the level of production is increasing. So they use more labor to produce more output of a pizza, and the number of ovens in the short run is not changed. Now we'll go to the cost side, and we see here ovens because they have two ovens. The cost of oven, which is input, the cost of these two ovens not changed over the production levels. So that's why it's fixed costs. So they still have to pay this 800 whether they produce or they don't produce. But as they produce more pizza from zero to a positive number, or from 0 to 200 pizza, they need to hire one more labor or worker, and the salary of this worker is for each worker is $650, and for additional output they have to hire additional worker. So they will pay for both workers 650 plus 650 is 1,300. So as you increase production, you need to hire more labor, and you will pay additional 650 as you increase production until you get to the level of 650 for 40, and you pay, or the firm pays 3,900. So as you notice that for additional worker, additional payment of labor is 650, and we said that workers or labor is a variable cost because it changes according to change in number of production or level of production or output. But oven, the cost of oven is fixed cost because they cannot change this in the short run. So yeah, they have to pay 800 at each production level. So if you add fixed cost to variable cost, this will result in total cost. So 800 plus 0 is 800, 800 plus 650 is 1,450, and so on and so forth. Now for this column, we have a new concept, which is easy one. It is called average total cost. Here you have to divide total cost over total output. So this is total cost and this is total output at each production level. So 800 over 0 is undefined. So you start with the second level, which is a positive number. So this total cost, 1,450 over 200, yields this average cost. And if you do it for each additional level of production, you divide total cost over total output, gives you these numbers. Average cost is also called unit cost. How much each unit you produce, how much it costs. So as you see in this number, if you are going to plot this in a graph, you will find that these numbers are coming from top level, and then it reduces to 4, and then it increases as we increase production. So just bear in mind that total cost, or in this case, I will call it total average cost. It begins from a number at the top, then it decreases, then it increases. It's like U shape. This is quantity and this is total average cost. And also if we plot this total output here, if we plot it, sorry, I'm going to continue here. If we plot these types of costs, we'll make this graph. This is quantity, and this is cost. All types of cost is here. So you see that this fixed cost is a fixed number. So if here is 800, and as you increase production, this cost is not changed. So this is fixed cost. And for variable cost, it starts with 0, and then it increases from 0 to higher numbers. So this is fixed, this is variable cost. And if we do it for total cost, so as you see, that total cost should start from 800, because it's addition of 800 plus fixed cost plus variable cost, which is 800 plus 0, so it's 800. So 800 is here. So we make it start from 800, and it becomes like this. So this is total cost. So total cost is higher than variable and fixed cost because it's addition of those variable and fixed cost. And total cost starts from where the fixed cost starts, because at this level here, variable cost is 0, as you see here. We just talked about the production function, so it's a relationship between input and output. In our case, it was Q pizza equals function in workers, which is labor, and capital, which is oven. And average cost is, as we saw, variable cost plus fixed cost equals total cost. So you take this total cost and divide it by total production for each level. It gives you average total or total average cost or average total cost. And these are the curves that we just drew them in slide number 11. So go to slide number 11. So this is total cost, and it starts from 800. So this is 800. And this is fixed cost. And here is going to be the variable cost. And this is the average cost, which is total cost over the level of production. It gives you U-shape average cost, average total cost. Okay, I want to go back again to talk about the production side. So if I'm going to draw the production curve, so but here we are interested to know how much production level we can produce by increasing number of labor. So labor 0, 1, 2, 3, 4 until we reach 6. And this is 100, 200, 300 until 700. So if we draw the curve here, as you see, the number is increasing. So this is 200, somewhere here 400, but it starts from 0. So it will do something like this. So this is called production function or production curve. Okay, we'll continue. We talked about this. Okay, again, here is production uh, side of analysis. So this is just a small cut of the table of slide number 11. We have all these information here, but the additional information is marginal product of labor. And as you know from the lectures, that the word marginal is is that we are looking at something related to difference. So from level to at another level, what is the difference? So so at this level of worker or number of workers, we have two ovens. So as we increase production, we need more labor. So going from production zero, level zero to 200, so the difference is 200, and going from production made by labor one to labor two, it's 450, and the difference between these two levels is 250. And going from labor two to labor three gives total quantity of production 550, and the difference between two levels is 100. So this is what is happening. And if you want to graph this, look at how the numbers are behaving. So it starts with the undefined level. So it starts with the second level, which is 200. Then it increases, and then it decreases, but we don't go to the minus level because production is a one-sided distribution, so it just has positive numbers. You cannot produce minus numbers. So if you graph these numbers, if you graph or draw graph for total quantities and marginal, you will find this relationship. If we put them here, so this curve is what we draw before, which is total quantity or total output related or in relation with the number of workers, one input. So as you increase input of labor, you get more production. And if you draw the graph for marginal product, you get this curve, which doesn't go into minus. But look at the relationships here. It mentions here when the marginal product of labor is increasing, with this when this is increasing, total output is increasing in an increasing rate. And when this is called reflection points, the point where the curve is turning from increasing rate to decreasing rate. This is decreasing rate. So here, when marginal, as it says here, when the marginal product of labor is decreasing, this is decreasing, but it isn't in positive uh, area. Total output is increasing, but in a decreasing rate or slow rate. So don't get confused here. So if marginal product of labor is decreasing or marginal production is decreasing, total production is increasing, but in a decreasing rate. Uh, so this has a philosophy here, but it's beyond our focus. I just said that it is beyond our focus, but here is just a small analysis of what was going on in these curves. So remember that we have a production function of pizza, which is function in labor, and oven, which is capital. And we said that oven is always fixed, but labor is variable. So when you add variable input to fixed input, you have three stages: increasing and inflection and decreasing. And this is what is happening. The marginal product is increasing because you are adding labor to fixed labor, which is variable input to fixed input, and fixed input is not appearing here, but it is reflected in this curve. So you have three stages. Marginal product increases, then it reaches the maximum, which is inflection point, and then it decreases. And this is what is happening there in this curve. As you see that the total product is increasing at increasing rate, and then it has inflection point where the rate of increasing becomes slower and slower. And why it's becoming slower? Because the more you add of labor to the oven, this will result in decreasing marginal production. And the next slide, it says this clearly. And what we just said is called law of diminishing returns, which is when you add more of a variable input, which is L labor, to a fixed input, which is oven is capital. This will cause marginal product of the variable input to decline because this is what's going to happen as we go and increase the level of output. We just explain this. Okay, we'll continue. This is average labor, average product of labor. If I go back to these numbers, yes, these numbers, and you take the total output or total production and if you divide the production at each level, if you divide this over the level of input, because this is average production per labor, per unit of labor. So if you divide 200 by 1 and 200, 450 by 2 and 550 by 3, and you will continue until 640 divided by 6. So all these numbers here, at each level, this is the average production per level of labor. And if you draw a graph, this is labor, 1, 2, until 6. And this is production. So I calculated for each one the average production. So it will be something like this. It starts from 200. This is 200. It goes to 225. Then it decreases. So if you put this here, you will see something like this. Something like this. So what you see that at the beginning, marginal product is greater than this average. This is average product and this is marginal product. And then it reaches maximum. Then when marginal product goes down, average product decreases. So this what is in this slide. So again, go to slide number 14. So we talked about marginal product and marginal cost. Marginal product and average product. Now we'll do more analysis on the cost side. So we will focus on marginal costs and average costs. And this is the formula for marginal cost is change in total cost because of change of the 1 unit change in production. Okay, just a quick reminder of when we talk about marginal cost, we have to recall also marginal product, and we have to call average product and total average cost so that we do not confuse. So here production and here costs. So in production we talked about marginal product. So it's change in total production because of change in the level of input, which is labor. And here marginal cost is change in total cost because of change in total production. So if you have a table, you see the level of workers and the level of production. And if you go from one level to another, so marginal product is the difference between this number and this number. This is marginal product. But in cost, you have level of production and you have level of total cost. So from one production level to another production level, and this has total cost level and another total cost level. So the difference between these two levels is marginal cost, and the difference between these two levels here is marginal product. So the base here is labor and the base here is total production. And the meaning of this this equation is taking difference. Also the meaning of this equation is taking difference because you are going from change of levels, the relationship of changes in levels between these two variables Q and L here in production, and total cost and total production in cost side. Okay, now what about average production here and average cost here? Average production is you divide total quantity over the level of labor or input. So you want to know how many quantities each labor or level of labor produced. So here it's division. So if you have L and Q, this is X, this is X, and X here and X here. Well, let's call this Y. this x1 to y1 and y2. So here you divide each one of those y1 over x1 and here y2 over x2. Now for average cost, we have many types of costs because we are breaking them down. So you have total cost and you have which equals variable cost plus fixed cost. So for each level you divide fixed cost over Q quantity. Again, notice there that we are dividing by the level of L. So it's Q divided by level of L. But here it's cost, type of cost over the level of Q. And here variable cost divided by level of production or output. And here total cost divided by level of production. So this one we call it average total cost, and this one average variable cost, and this one average fixed cost. Again, variable cost over Q plus fixed cost over Q equals total cost over Q, or we call it average variable cost plus average fixed cost equals average total cost. Okay, let's go to next class. Next slide. Now here the focus is on the cost side, average costs, and also marginal cost. So the calculation of these. So we have two things to do to know what the marginal cost and to know the average costs, which are three types: variable cost, fixed cost, and total cost. So once you do it, it becomes average total cost, average fixed cost, and average variable cost. And those costs are related to production level when you calculate them. So see here, this is number of workers, but we are focusing on this one, quantity of a production. So this has to be quantity of production. This is wrong. This should be quantity of production of pizza. So first, this is marginal cost here. So you go from level to another, that you take the difference. So for 200 minus 0, it's 200. 450 minus 200, it's 250. 550 minus 450, it's 100, so on and so forth. And this is total cost. If you remember that variable cost plus fixed cost. Fixed cost is 800 at level 0, because if it doesn't produce, still the firm has to pay this 800 because it's fixed cost. And then by adding the first labor, the cost of first labor is, so if you remember, the cost of labor is 650. So for example, the total cost of this, you have two labors plus 800 equals this to 10. And also you can do also for this one, You multiply 650 in 3 labels and plus 800, you will get this. So you continue this until you come to the last one, which is 6 labels. So after this total cost is finished, you can figure out marginal cost. And marginal cost is you take the difference between total costs, the current one minus the previous one, and for this one, the current one minus the previous one. Okay, I'm sorry because the label here is not matching, or it's incorrect. The label here, notice please, because the label here is incorrect. So what I did just a second ago is to calculate marginal cost, but this is not marginal cost. So the table here is totally given in incorrect way, so better to forget this. But the interesting part that we want to focus, or better to focus on here, is this relationship between the curve of marginal cost and the curve of average total cost. And you can divide the analysis here by starting from this point and say that when average total costs reaches its minimum, marginal cost intersects average total cost. So the intersection comes at this point at the minimum level of average total cost. And when total cost is decreasing, average total cost is decreasing, average total cost is greater than marginal cost. But when average total cost is increasing, marginal cost is greater than average total cost. Okay. Again, the same analysis here. Look at the average total cost, and this is marginal cost. So, and take this point. So this point is the minimum of average total cost. When it reaches the minimum, marginal cost intersects it. And when average total cost is decreasing, marginal cost is below average total cost, which means less. But when average total cost is increasing, marginal cost is greater than average total cost. All what we are doing now, we will find the reasoning behind what we are doing now later when we go to finding out the profitability in other types of markets, like competitive market, monopolistic market, and monopoly, and so on. We talked about all these in the previous slides. Again, also the relationship between different types of costs. So this is marginal cost, and this is average total cost. We just talked about this, looking at the minimum. The same analysis is true here as well. So this point that we just talked about, so when average total cost reaches the minimum, marginal cost intersects it. Same analysis is also true when we talk about average variable cost. So when it reaches the minimum, marginal cost intersects it at minimum of average variable cost, but average fixed cost is always decreasing. These relationships could come in multiple choice questions. But again, the reasoning of what we are doing will be much clearer when we talk about different types of markets. Okay, then we'll go to the next slide. Okay, let me shift this slide to come before the slide number now 26, because this is related to the curves in the previous slide. So 24 and 25, slides 24 and 25 are very related to each other. And slide number 25 explains the behavior and the interrelationship between the curves here. So if we read the marginal cost, average total cost, and average cost curves are all U-shapes. This is what we see here. All of them are U-shaped except average fixed cost. And when marginal cost is less than either average variable costs or average total costs, it causes them to decrease. So this is what it says here. So when marginal cost, this is marginal cost, is below the average variable cost and average total cost, it make them all to decrease. So the rest of explanation is similar to what we said before. These minimum levels of the curves, when they are at minimum, the marginal cost will intersect them all. So all what we said before is explained here. And as I said, it could come in multiple choice questions. And in the future, all these curves will help us in making analysis, in figuring out the profitability that could happen in situations of different markets, monopoly, duopoly, monopolistic competition, and perfect competition in the coming chapters. Okay, now we'll go to this table, which is important, and it is on the cost side, and it also related to the curves. So in general, if we take these numbers and then plot it in Excel, we will find something similar to curves like this in slide 24. Anyway, we need to know the behavior of these numbers and how we can get it and how we can calculate them. Again, this is production side, and this is cost side. This is production side, and this is the quantity of production. We have labor and we have capital, which is oven. As number of labor increases, this is the fixed input. This is the variable input, and oven is fixed input. And this is production. As you see, the production increases as labor increases. Note that we don't make any calculation of marginal product and average product here, but don't worry, it will be similar to the tables before. Okay, then in this side, it's all about the cost. So this is fixed cost because it's related to the input of K, and it's fixed over all units of production. And when production is 0, no labor is used or hired, then this is the fixed cost. And the fixed cost in this case equals total cost, because variable cost is 0. This is variable cost. This is fixed cost, and this is total cost. And this is the first cost of the first unit of labor, which is 650. So as you increase labor, you have to increase also the variable cost. It's related to the production, and you add these, you will get total cost. Then you get, so again, if you also, as we said, that we get the average total cost by dividing total cost by level of production. So we'll get this column, and then for average fixed cost, go to the data on average fixed cost, which is this one, divided by the number of production for each level. You will get this column. And then for the average variable cost, go to variable cost and take the numbers and divide them by each on the level of production or quantity level. And then you will get this number here. And note that as we said, that average total cost is equal to average fixed cost plus average variable cost. So if you add this to this, you will get this. If you add this to this, you will get this. And then for marginal cost, you will. So for marginal cost, be careful here, because the way it is done is by using this formula, change in total cost because of change in quantity level. So change in total cost, that's a new cost or current cost, minus previous cost so new cost minus previous cost divided by a new quantity minus previous quantity. So if you take this number, for example, because it's easier to understand, so this is the latest total cost, 4,700, minus the previous one, which is this one. It's the difference, as we said before, but here the way is a bit different, because we are taking momentum change. And new quantity, this is a quantity, so this is the new quantity, 640 minus the previous quantity, which is this one, 625. So this 650, and this one is 15, and this will result in this number, 4333. So check this with this number here, it will be the same. So again, you will do same way of calculation. If you take this number, so this will be the new level, and this is the previous level. So it's 4 0.50 minus 3,400 over 625 minus 600, which is similar to this one. So do this until you complete this column, and by that you will finish the process of calculations for all related types of costs. So for this slide, the idea here is based on the fact that as we increase level of production, we should get lower cost per level of production. So it is exactly here. So the average cost will fall as you increase output. So if you take total cost and divide by Q, over time, this cost should decrease. This is very true when you compare fixed cost, when you divide fixed cost on Q. So if you go back to this, you just take this average fixed cost. You see that as you increase the level of production, what will happen to average fixed cost? It's 4, then 1.7, then 1.45, 1.3, 1.2, then 1.25. And we have drawn this before. Average fixed cost. We said that the curve is like this. So this means as you increase quantity, the average fixed cost decrease. So this is called scale economies or economies of scale. So as the scale increases, the unit cost goes down. This is very true when you have a lot of fixed costs. For example, airline companies, they have a lot of fixed costs. Real estate companies, they have a lot of fixed costs because of buildings. So as they make more operations, the level of cost will decrease, because if they don't do any operations, their level of cost is high. So as they make a lot of operations, I mean, they produce more, then they do more activities, the per unit cost will decrease. So this is called scale economies. So the idea here is that in the long run, as firms or firm expands its operation, their unit costs will decrease, should decrease, and if they get to this result, then they are making scale economies. If we go to the next slide, so this scale economies in the long run. So what happens, or what this explains? Just take one of these U-shaped cost. This is average total cost. Average. Each one of them is average total cost. So what do you see in the U-turn? You see that it has a minimum level here, which is here. So these costs are in the short run. In the short run, as we studied before, all of them are U-shaped. This is average total cost. This is not fixed cost. This is fixed cost plus variable cost gives average total cost. So it's U-shaped. And this is in the short run. So if company starts with this level, and if it expands its operation, it has a lot of fixed costs. So the unit cost should decrease over time. So if they increase the level of production and activities, their minimum cost will decrease in the next stage. The minimum cost will decrease. And if they expand more and more, so they increase the level of production from 20 to 40, then their unit cost will decrease more and more. But this is in time. And after a certain time in the long time, the market might experience a lot of competition. So this will raise the minimum cost. So if we trace all these tangible curves, tangible to long, this is long-term average total cost, because we trace them. So we will find again U-shaped long-term cost, which shows scale economies. Scale economies, which means as you increase production, the minimum cost should increase because of average total cost will experience lower unit cost as production increases. And this is also true for if the market has many companies with different scales. So this is scale, and these are big companies, and these are bigger companies. So bigger companies will have lower minimum costs because of higher production. So this cost decreases as quantity increases. That's why big companies like Amazon, Carrefour, Lulu, they operate in very large quantities. So their total or average total cost is at much lower or minimum level than if you compare it with groceries. If you go to groceries, they have to sell at higher prices because their minimum to cover their minimum cost, but they cannot set prices lower than their minimum cost. But those big companies like Lulu and Carrefour, Amazon, they can set prices at lower than minimum cost of other groceries because their minimum cost that they operate on is much lower, so they can afford to charge lower prices than any other available smaller size of groceries. This is in the supermarket industry. So just we'll focus on this long-term curve of average. This is long-term average. L is long-term average total cost, and we get this long-term average total cost after we combined many of those short-term average total cost. So now we'll go to the next slide to have some more analysis on this cost. So this is the minimum from here to here. This is the minimum cost. So if you operate at this level of Q, so this is cost, or you operate at this level of Q or this level of Q, your cost is same, constant. It's constant return to scale. So it's better for you to increase Q until you reach here before the curve goes up. This is for companies which operate at a large scale, like Amazon. They sell a lot of items, Carrefour, supermarkets, and Shaheen in Qatar. So it's better for them to increase their queue until just before this level, because at this level all costs are exhausted. That's why it says here the level of output at which economies of scale are exhausted. It's here, it's exhausted, because after this the curve will go up and the minimum cost will increase for unit of production. And this part is diseconomies of scale, because if you produce here, it's better than here, because here you have higher cost. So if you go further and further, you have more economies of scale. But this part is, if you compare it to this part is diseconomies of scale, and this is constant scale economies, and this is sorry, I have to repeat this again. So I should say that this part here is diseconomies of scale. This part here is diseconomies of scale. This means as you increase Q, then your cost goes up. So if you are here, your cost is going to increase, because the unit cost for increases. So per unit production, the cost increases here. So this is called diseconomies of scale. But this part is economies of scale. So economies of scale, why? Because as you increase Q, your cost decreases. If you compare this to this, you will find that Q here has lower cost than Q here. So this means economies of scale. So this part, economies of scale, this is constant scale economies, and this is diseconomies of scale. Oh, okay, I think we finished all what we need to say for this chapter, and thank you.